I just killed my manager. Of course, I'm talking about queue manager and IBM on queue. Please don't kill your real manager. But the purpose of that in IBM MQ uniform cluster is to achieve high availability. So you can kill as many queue managers as you want and everything still will be working. Because anything can happen. Network issues, availability issues, data center issues, anything can happen. And in enterprise real production, you need to be assured that all messages will be delivered. I'm Alexander Khalikov. I work with integration software for many years. Subscribe to my channel, and today I will show you how to use IBM MQ uniform cluster with consumer and producer applications written in Golang. Let's code. Here's what I built. It's a simple application just with one consumer, one producer, and 3 queue managers in a setup of a uniform cluster. So, in my Docker Compose file, I'll show you what I have. 3 services, QM1, QM2, and QM3. They're almost the same, apart from the name, obviously. So it's queue manager number 1, queue manager number 2, and queue manager number 3. So to achieve high availability in IBM MQ in a uniform cluster, you need at least 3 queue managers, because in case one of them will die, you will still have 2 queue managers to run your queues. Setup is very simple. So just the username, standard password, and the name of the MQ cluster itself. Volumes are also very simple. So it's QM1 data, QM2 data, QM3 data. And for the network, I will use the same network. In this case, it will be a bridge network, right? So we have a connection between all 3 queue managers in the form of a uniform cluster in MQ. In producer application, what I have also very simple application. So I'm just using standard IBM MQ library for Golang available on GitHub and the connection to my cluster. So to start producing messages to your cluster, what you need to connect to the cluster itself. For that case, you can use that connect to cluster function. And again, just following instruction in the standard library for Golang, you just need to provide credentials to it, username, password, the name of your cluster itself, and you can start producing messages to it following instruction in an official library. So it's a very simple application, as I said. We're just going to produce 200 messages spread out across 3 queue managers. But in the second run of that application, we're going to kill one of the queue managers and we will left with only 2. But the main thing about that scenario is that we don't need to reset connections to queue managers themselves because we are connecting to the cluster, right? So if you're going to add new queue managers, if you're going to delete your current queue managers, you don't need to rebuild your application because you're going to consume messages from the cluster and you're going to produce messages to cluster, not to a single queue manager. Consumer application, about the same, apart from the fact that we're going to get messages from cluster, not put messages to cluster. So in MQ terminology, when you producing messages to your queues, you're putting messages to your queues, and when you receiving messages from your queue, you getting messages from your queue. Here's the current status of my application. First, we're going to run Docker container list. So as you can see, we got 3 queue managers running in the cluster right now. They're only 25 minutes old. Okay. In the second terminal, I will start consuming my messages. So my consumer application will wait until messages will appear in the queue. I will run this command, run consumer. Consumer is up and running. As you can see, it is waiting for messages to be consumed from queue. But because we haven't produced any messages to our cluster, we don't have these messages yet. And in the third terminal, what I'm going to do, I'm going to make my producer up and running, and I will switch very fast to my consumer because as you can see, we only have 200 messages in this demo, right? And these messages were consumed very fast. Maybe because we have 3 queue managers, so we will see if that will be a bit slower when we will kill the second or third or the first queue manager. So we can't, consume these messages as fast as we can. But with 200 messages, it's probably very hard to show because, well, MQ is very fast and Golang is very fast. So let's do our best, okay? Let's just stop one of the containers from our cluster, right? So what I'm going to do, I'm going to docker stop and pick one of the containers. Okay, so now when I'm doing docker container list, I can see that 5 seconds ago, queue manager number 2 was stopped. Now I can run this setup again. I will run my consumer and I will run my producer. I'll switch to consumer. Everything's working. It's still working. And you could do it with any queue manager. Let's just give it a try with queue manager number 1. Probably it still will be running, but it will be a bit slower. But as I said, with just 200 messages, it really doesn't matter how many queue managers you have in terms of speed, not in terms of high availability of them. So I will docker stop another container. Currently, when I'm running docker container list, I see that only one container is healthy. However, when I run my consumer again, and I run my producer again, I still can consume messages. That's the demonstration of high availability. So even if your queue managers are down, you still can consume messages. And if you want to run a full high availability test, you can run one of the commands from the instruction to my make file. The demo that I'm going to run right now, I call that failover demo. From the name, you can guess that it will create 3 queue managers. It will start producing messages to the cluster, and in the middle of that demo, it will stop one of the queue managers and still will be able to consume messages from a cluster. We're waiting for queue managers to be ready. Currently, all 3 are running, and we're sending 50 messages to the cluster. Now we stopped queue manager number 2, and we got queue manager 1 and 3 remaining. We continue to send messages to cluster. We restarted queue manager number 2. And we're waiting for queue manager number 2 to rejoin the cluster. Now we're sending the final batch of messages. So we sent 150 messages in total. 50 messages to all 3 queue managers. Then we stopped one of them, sent another 50 messages, received them, then we rejoined queue manager number 2 to our cluster, sent another 50 messages, and consumed them. This demonstrates high availability of IBM MQ in the form of a uniform cluster with Golang consumer and producer application. Thank you very much. I'm Alexander Halikov. Subscribe to my channel, watch my other videos, and leave a comment. And code for this particular demo will be available on my GitHub. Bye!